Hi Chemistry, this is KJ here, and I'm going to go over the 2.08 review, Molarity, Molality. Review concepts presented in the lessons molarity and mole fraction, as well as molality and mass percent. There are many ways to describe the concentration of a solution. This review lesson focuses on some of the most important ones. So the goal, demonstrate mastery of the important knowledge in the lessons molarity and mole fraction, and molality and mass percent. Key concepts in molarity and mole fraction. Molarity, capital italic M, is the number of moles of a solute in 1 liter of a solution. Molarity is equal to the number of moles of solute divided by the amount liters of the solution. Mole fraction involves the number of moles of either the solute or the solvent compared to the total number of moles in the entire solution. Mole fraction of the solute equals number of moles of solute divided by total number of moles of solution. Mole fraction of solution equals the number of moles of solution divided by the total number of moles of solution, which you'll never use. I'm pretty sure they meant mole fraction of solvent is the number of moles of solvent divided by the total number of moles in solution. So concentration is expressed as grams per liter, in the mole fraction as in moles per mole, in molarity as in moles per liter. Key concepts in molality and mass percent. When both the solute and solvent are liquids, determine the concentration by using volume percents. The percent by volume equals volume of solute divided by volume of solution times 100%. Concentration can also be described in terms of mass percent. The percent by mass equals mass of the solute divided by the mass of the solvent times 100%. Molality, lowercase m italics, is a measurement of the number of moles of solute in 1 kilogram of solvent. Molality equals moles of solute divided by kilograms of solvent. So concentration can be expressed as molality, which is moles per kilogram. Now you need to look at the problem set, and then if there's some websites to find some more information, if you're interested, go ahead and go to those. And all right, so to go to that, we need to go to your problems manual. So we go up to the top, right here, problems and solutions, and a laboratory guide. When you click on it, you can click here to access chemistry, problems, and solutions. And then you can go ahead and go to page 142. I knew it was page 142 because I downloaded the answer keys, which were in the student guide, which was on slide number 2. Molarity and mole fraction. Molarity and mole fraction are two ways of expressing the concentration of a solution. Many important chemical reactions occur in solution. The amount of various solutes in a given amount of solution has a significant effect on the rate at which these reactions occur. The amount of solute in a given amount of solution is the solute's concentration in the solution. Chemists express concentration in several ways. The most common way of expressing concentration is as molarity. The molarity of a solute in solution is the number of moles of the solute in 1 liter of solution. The symbol for molarity of the solution is capital italics M. Another common way of expressing concentration, especially for mixtures of gases, is as mole fraction. The mole fraction of a substance in a mixture is the ratio of the number of moles of the substance to the total number of moles of all substances in the mixture. Because mole fraction is a ratio, it has no units. All right, our objectives: define molarity and mole fraction, perform calculations involving molarity and mole fraction. We'll do the green column next. Remember, molarity and mole fraction. The molarity of a solute in a solution, capital italics M, is the number of moles of the solute that are dissolved in 1 liter of solution. Molarity is generally used to describe the concentration of solutions in which the solvent is a liquid. The mole fraction of a substance in a mixture is the ratio of the number of moles of the substances in the mixture to the total number of moles of all substances in the mixture. Mole fraction is represented by the symbol capital X. I think it's also supposed to be italicized. Honestly, you don't see it all that often, so not the biggest, most important thing to remember. Mole fraction is most often used to express the proportions of components in mixtures in which all the components are in the same phase. For example, mole fraction is often used to describe the compositions of mixtures of gases, so where both the solvent and solute are gases, or mixtures of liquids, so where both the solute and the solvent are liquids. All right, example 1, calculate molarity from moles. A student dissolves 0.080 moles NaCl and 0.025 moles CuSO4 in enough water to form 3.50 liters of solution. What is the molarity of each solute in the solution? Okay, so first things first, you're going to write down everything. So how many moles of each you have and the volume of the solution. It says collect and strategize. Molarity is defined as the number of moles of solute per liter of solution. Therefore, to calculate the molarity of this solution, divide the number of moles of each solute by the number of liters of solution to calculate molarity. So here's your information. And so we'd say, okay, we have 0.08 moles of NaCl sitting in 3.5 liter solution. And when we do that, we end up with 0.023. So if you put in your calculator 0.08 divided by 3.5, you're going to get 0.23, and that's moles of sodium chloride in 1 liter. Do the same thing for the copper sulfate. We take our number of moles. Sorry if you heard that, my little girl ran over real quick. So for the copper sulfate, we take 0.025 moles of copper sulfate that is sitting in 3.5 liters of solution. Simply divide those out. That gives you the fact that you have 0.0071 moles in 1 liter. So the concentration of NaCl in the solution is 0.023 molar, and the concentration of copper sulfate in the solution is 0.0071 molar. Another way to express this is to say that the solution is 0.023 molar in salt and 0.0071 molar in copper sulfate. Really, the key to these is listing what you know and then making sure you know what you want to end up with. Calculate molarity from grams. A mass of 80 grams of calcium bromide is dissolved in enough water to form 2 liters of solution. What is the molarity of the solution? Okay, so again, we start by writing everything down that we know. We know the mass is 80 grams. We know that the total volume of the solution is 2 liters. And it says first calculate the number of moles of calcium bromide. Then divide the number of moles by the number of liters of solution to calculate the molarity. This example gives this information. Now, we started out with what we know, 80 grams of calcium bromide. What has to go on the bottom of our next fraction? Grams of calcium bromide. Use your periodic table and add up that there's 1 calcium atom and there's 2 bromine atoms. And that gives us a molar mass of 199.9 grams in 1 mole. So that tells us we have 0.4 moles of calcium bromide. We know we needed to get moles because molarity is moles per liter, and we started with grams. So we changed the grams to moles, and then we just said, okay, we have 0.4 moles in 2 liters, divide that out, and we get an answer of 0.2 molar. Therefore, this is a 0.2 molar solution of calcium bromide. And I'm just checking over the tips real quick. All right, so calculate the mass from volume and molarity. How many grams of silver nitrate are in 500 milliliters of 0.1 molar AgNO3 solution? So first thing, write down what you know, okay? And then think, what do we want to get to? Okay, well this time we want to get to grams. And what did they give us? They gave us molar, so that's mole per liter, and they gave us the volume of the solution. So to solve this problem, first use the molarity and the volume of the solution to calculate the number of moles of silver nitrate. Then use the molar mass of silver nitrate to convert moles to grams. So you're working backwards. So we start out with what we know, and 500 milliliters, divide that by 1,000 milliliters is equal to 1 liter. Okay, so that breaks that down to tell us that we basically have half a liter, right? And with that then, we have 0.1 moles of AgNO3. So the molarity of the solution is 0.10 molar. Therefore, 1 liter of solution contains 0.10 moles of AgNO3. Use this concentration as a conversion factor to calculate the number of moles of AgNO3 in 500 milliliters of solution, as shown below. Remember to convert milliliters to liters. In other words, really, you could have also said, okay, I got half a liter. So in 1 liter, I have 0.1, divide 0.1 by 2, and I got 0.05. Now use the molar mass of sodium nitrite as a conversion factor to calculate the mass of silver nitrate in the solution as shown. So we have 0.05 moles. Moles has to go on the bottom to cancel it off. In 1 mole of AgNO3, if we look on our periodic table and add up how much each of these have for a mass, we get 169.9 grams. Put in your calculator, you get 8.5 grams of silver nitrate. All right, example 4. Calculate the mole fraction from moles. A particular sample of air contains 2.694 moles of nitrogen gas, 0.725 moles of oxygen gas, and 0.032 moles of argon gas. What is the mole fraction of each gas in the total sample of air? So, same thing. We write down everything that we know to start with. To calculate mole fraction, first find the total number of moles of all substances in the sample. All right, so this tells us them individually, and then we need to add these up to get our total moles. So if we add up 2.694 plus 0.725 plus 0.032, that gives us 3.451 moles. Then all we got to do is divide each one. So we say for nitrogen, we take the amount, 2.694, divided by our total amount, which is 3.451, and that gives us 0.7806. And you do the same thing for the rest of them. Now, if you add these up, this should equal 1. Okay, just like you multiplied by 100 and add them up, you would get 100%. So when you have a mole ratio, if you do all the components of it, you add up your final answers, your answer will be 1. All right. Hang on, let me back up. Did I not scroll down far enough? Nope. Oh, okay, there you go. Example number 5. Calculate mole fraction from mass. A scientist makes a solution of ethanol and water by combining 36.9 grams of ethanol and 21.6 grams of water. What are the mole fractions of ethanol and water in the solution? Collect. So again, list the information that you know. To calculate mole fraction, you must know the number of moles of each substance. From the periodic table, the molar mass of ethanol is 46.068 grams per mole, and the molar mass of water is 18.015 grams per mole. They started out with grams. We need to convert it to moles. So if I take my 36.9 grams of ethanol, put the molar mass on the bottom of the next fraction, my grams cancel off, and I get 0.801 moles of ethanol. I started out with 21.6 grams of water. I put the molar mass on the bottom, which is 18.015 grams of water. That's the same as 1 mole. And I do my math, and I get 1.20 moles of water. Now I need to find the mole ratio. So I got to add these two up to get my total moles, and that's 2.0. So I divide how many moles of ethanol by 2.0, divide how many moles of water, 1.2, by our total, which is 2, and I get 0.6. When you add these up, what should it equal? It should equal 1. And that's what it equals 1.001. That's close enough. It's within rounding. If you think about money, that would be less than a penny, so no big deal. All right, and now we have the problem sets to go over. I will do those in the next recording. However, I can't emphasize enough. It's so important. Watch this again. Hit pause at the beginning of every example. And just read the top part. Cover up part of your screen if you need to with a piece of paper. Solve it yourself and check your answer. Just listening to me go through these is not going to help nearly as much as if you go through these and do them all yourself. If you need help, come see me.